Hey guys, how's it going? Today I want to talk to you about section 8.2. It's called factoring by GCF, or factoring by the greatest common factor. So now that we know how to find the greatest common factor, now we can actually start factoring by it, okay? So the first thing you got to do is figure out what is the greatest common factor, right? So basically just look to see, what do these things have in common? Well, what can you divide both the 4x squared and the 3x by? Well, you can divide them both by x. And if you do that, if you actually factor that out of there, if you just divide it out, if you pull out an x out of this 4x squared, all you'd be left with is 4x. And then if you do the same thing with this, if you divide that by x, all you're going to be left with is -3. A lot of people call this reverse distributing or undistributing, so to speak. And that is an easy way to check. You should always be able to check your answer by taking that x and redistributing it back in, and you should be able to get yourself back to where you started, okay? And that's really about all we're doing here, is we're just undistributing, so to speak. Let's try another one. And you can look for, see what all three of these terms have in common. And that's what we need to try to do. Well, all three of these terms, you can divide them all by 5. But they also all can be divided by a y. Okay? And if we do that, if we divide this by 5y, 10 divided by 5 is 2. Y to the third divided by, take a y out, you're still left with y squared. We do the same thing here. The 20y squared divided by 5y would be 4y. And then the 5y divided by 5y is a -1. Again, you should be able to distribute that 5y back in to check your answer and get back to where you started. Okay? Let's try another one here. Sometimes you're dealing with something that looks like this with some negatives. Well, I think that looks pretty ugly. So what I'm going to do is I'm going to pull out a negative here. And then I'm going to look to see what else can I divide both these two terms by. Well, I can divide them both by a 4, right? Well, when I do that, -12 divided by -4 is a +3. -8 divided by -4 is a +2, and then I would still have that x squared, right? Now, this is technically correct. I think this might look a little bit better because the x squared kind of looks weird being second. You can flip-flop those two things and make it look a little bit better. I think that's a better looking answer, but that would not be correct, or that would not be incorrect. Okay, that would be correct as well. Both of those are correct answers. Sometimes you can look for even bigger things that they have in common. If you look at this whole thing as one term, and then you look at this whole thing as one term, and you can do that because it's multiplication, well, they both have an x -3. So you can pull that out. And if you divide this by x -3, you're just left with the 7. And if you divide this whole thing by x -3, you're just left with the -2x. And you're done. And again, you should be able to FOIL that out, and it should be the same thing as if you distribute those. Same thing down here. What does this whole term here have that this whole term also has? Well, they both have an x +4. And if you divide this out, all you have left is a 9x. And if you divide the x -4 out down here, you just have that -5. Okay? So these kind of problems actually lead me to what we call factor by grouping. Now, we call it factor by grouping because the first thing we look to do is, can we divide all 4 of those terms by something? Well, you can divide by 3a, only 3 of the 4 have an a. You can divide that by 3, divide that by 3, that by 3, but that can't be divided by 3. And so there just is nothing you can divide them all by. But there is a lot in common with just these two, right? Those two terms I can pull out I can divide by 3, and I can also divide by an a squared. So if I just kind of treat these two as a problem, kind of ignore that second part for a minute. Just don't even worry about that going on back there. Just dividing those first two terms. If I do that, I get a 4, and I get an a, right? Divided 12 by 3, I get 4. Take out 2 a's, I'm left with 1a. Divide this by the 3a squared, and I'd be left with -3, and the a's would all be gone. And then I treat this as a second problem kind of thing. And what can I divide both of those by? Well, I can divide both of those by a 5. And if I do that, 20a divided by 5 would be 4a. And the 15 divided by 5, negative, would be a -3. But now if you notice, these two terms have something in common. They both have that 4a minus 3. So now I can pull out that 4a minus 3. And if I pull it out of here, I'm just left with a 3a squared. Pull it out of here, and I'm just left with a 5. So that would be your answer. And again, I should be able to check my answer. I should be able to check and go 4a minus 3 and 3a squared plus 5. Foil those together. So let's see, 4a times the 3a squared would be 12a to the third. 4a times the 5 would be 20a. The 3 and the 3a would be -9a squared. And the -3 and the 5 would be 15. And that is the same thing as that. The only difference is those are backwards, which is okay. Okay? Let's try another one of those factored by grouping. Again, nothing I can divide all 4 terms for. I always look for that first. Because if you can do that, you can always make your life a little easier. Make numbers smaller. But I just look at these first 2 terms. What can I divide those first 2 terms by? Well, I can divide them both by a 9 and an x squared, right? And if I do that, take out a 9 and an x squared out of this, all I'd be left with is an x. And if I divide it out of here, I would just be left with a 2. And there's nothing I can divide that by. But now if you notice, there is a lot in common. That is the same thing as this. And if you imagine this as the same thing as if I would have pulled out a 1, right? Now I can pull out that x plus 2. And if I do that, all I'm left with is this 9x squared. And then over here, I would just be left with a 1. And again, I should be able to foil that out, double check my answer, okay? And then sometimes you're going to see things that we call opposites, right? Factoring of the opposites. It's the exact same idea, factoring by grouping. You know, you just look at this problem and go, don't even worry about the word opposite right now. We're just trying to factor by grouping. What do these first 2 terms have in common? Well, first of all, we look at, there's nothing we can divide everything by. So we go grouping. All right, what can I divide those by? I can divide them by a 3 and an x squared, right? So I do that, and if I take out a 3x squared out of this, I'm just left with an x. Pull out a 3x squared out of there, I'm just left with a 5. And then what can I divide both of those by? Well, I can divide them both by a 2. I do that, and I get a 5. And I divide this by 2, and I get a -x. Well, now I look at this, and I go, in here, it's really close, right? I have an x minus 5 and a 5 minus x. Those are not the same thing. Those are what we call opposites, right? So because they're opposites, what we really should have done here is if you ever see opposites, think, you know what I should have done? In one of the 2, it really doesn't matter. I would always do it in the second one. I could have, instead of pulling out a positive 2 here, I could have pulled out a -2. And if I pull out a -2 instead of a positive 2, right? So I'm kind of ignoring this step for a second, going back to here. Pull out a -2. Well, now that 5 turns into a -5. And that negative 2x divided by negative 2 is a positive x. And this really is the same thing as x minus 5. So now, if we look at this as factor by grouping again, now the x minus 5s are exactly the same. So I can pull out that x minus 5, leaving me with the 3x squared out of this term and just the negative 2 out of that term. Okay, so if you ever see opposites like that, just think, you know what, I should have pulled out a negative with it as well. And try that, and I'll bet you'll end up with the same thing that you can pull out. Try a few problems. I'm going to post some pictures of the book work out of this, so let me know how it goes, okay? And remember, send me a picture of anything that you tried, even if you don't do everything. Just send me a picture of any math you get done, all right? I will talk to you.